Alright, so in section 2 we're going to look at multiplying and dividing rational expressions. Now if I think of multiplying two fractions, let's say I'm multiplying 2/3 times 5 over 2. Now the traditional way to multiply these fractions is we can just multiply the top, so 2 times 5 is 10, and multiply the bottoms, 3 times 2 is 6. So we get 10/6. And then we can reduce this by dividing top and bottom by 2, so the simplified quotient would be 5/3. So we multiply the tops, we multiply the bottoms, and that works just fine. Another method we can do, that you may have seen in the past, is if I'm multiplying 2/3 times 5/2, since they have both a 2 on the top and bottom, a 2 here and a 2 here, I can cancel those out. So those 2 over 2 would just leave 1 and 1. So if we have 1 times 5, we have 5. 3 times 1, we have 2. So there is my simplified fraction. So that definitely works as well. So we'll use the same idea to multiply rational expressions. So we can say for rational expressions, if we have a over b times c over d, and we'll say a, b, and c are some kind of rational expressions, or some kind of polynomial, doesn't matter, then this is always equal to AC over BD. So we multiply the tops and we multiply the bottoms. Okay, so let's look at some examples where we have some more involved polynomials multiplying. So we have 8x over 21y cubed times 7y squared over 16x cubed. Now I can multiply these straight across, 8 times 7, and do all that, but I'm going to try the idea where I'd like to cancel either up and down or across. You can never cancel left and right, but you can always cancel up and down or across. So there are really no factoring to do here because this is just monomials. But what I can see here is I have 8 on the top here and 16 on the bottom here. So I can divide those both by 8, so that will leave me 1 and 2. Same thing for the 7 and 21. 7 and 21 both divide by 7, that will leave me 1 and 3. So since it's already kind of factored, we're just going to basically cancel things out. Here we have 1x on the top, if you see this x, and 3 x's on the bottom here. So if I cancel those out, that's going to leave me 2 x's on the bottom, similar to what we did in the previous section. So the 1x here cancels with one of them there and leaves 2. Finally, if we look at the y terms, we have y squared and y cubed. We can cancel 2 of the y's here with the 3 down here and leave just 1. So that would just leave y. So we've canceled a bunch of stuff. So if you look at the top, we basically canceled everything except for these 1's. So 1 times 1 is 1. On the bottom, I have 3y times 2x squared, which is 6x squared y. So this is my product. Multiply the tops, multiply the bottoms. Once you have everything canceled, and that's your product. Okay, let's look at the second example. Now, this one we have some pluses and minuses, so we'll have some factoring to do. So 1 plus 3n, there's nothing, no GCF, nothing really to factor, so that just stays as 1 plus 3n. 2n is 2n, so that just kind of stays the same. For the top right one here, this 2n minus 4, I can divide them both by 2, so I'll take a 2 out, n minus 2, when I take a 2 out of both of those. And now the bottom here, I'll have to do some of the factoring. So I'm just going to kind of pull this guy down here, and I'm going to try to factor him. There's no common factor, so I'll use my box factoring. So 3 times negative 1 is negative 3. So I'm looking for two things that multiply to negative 3, add to negative 2, so that's negative 3, positive 1. So in my box, there's my 3n squared. There's my negative 1 from the original polynomial. Then I have my negative 3n and my positive n. So out of the first row, I can take out 3n. Out of the second row, I can take out just 1. Out of the first column, I can take out n. And out of the second column, they're both negative, and the first one's negative more off, so I'll take a negative 1 out. So my two factors are going to be 3n plus 1 and n minus 1. So let's look at the next one. So a little bit of factoring here. So the first one we have x squared minus 16. So if I factor that, that's a difference of squares, x and x, 4 and 4. So this will factor as x plus 4, x minus 4. The bottom is just x plus 2, so that's not really going to go anywhere. The other two are a little more involved factoring, so I'll kind of write these to the side so I can factor them. Now they both have 1, which is our easier way to factor. So we have 2. So I'm looking for two numbers that multiply to 2, add to 3, which is 2 and 1. 2 times 1 is 2, 2 plus 1 is 3. Now we could do the box factoring, but we really don't need to, because if the first number is 1, I could just know that my two factors are x plus 2, x plus 1. So this top polynomial, we know factors as x plus 2, x plus 1. And we'll do the same thing with this bottom one here. X squared minus 3x minus 4. If I multiply 1 and negative 4, I get negative 4. If I think of two numbers that multiply to negative 4, add to negative 3, that's negative 4 and 1. So again, since the first term is 1, I know my two factors are going to be x minus 4, x plus 1. Again, if you use the rectangle and do all the stuff, it turns out the same, just to save us a little time when the first term is 1. So now I've got everything factored, so anything that cancels up and down or diagonally, so x minus 4, x minus 4, x plus 1, x plus 1, and x plus 2, x plus 2. So basically everything cancels out except for the x plus 4. So this product is just x plus 4. If you want to put something on the bottom, you could put 1, but you really don't need to put anything on the bottom. If there's nothing left on the top, you certainly need to have a 1, but on the bottom it doesn't really matter. Alright, if you recall when you divide fractions, such as 2/3 divided by 2/7, division of fractions, we actually turn this into multiplication of fractions. So we rewrite this as 2/3 times the reciprocal, which is 7/2. This is a pretty standard way to divide fractions, so instead of dividing them, we multiply by the reciprocal. So 2/3 divided by 2/7 becomes 2/3 times 7/2. Then my 2's can cancel out, and this just becomes 7/3. So in general, if we're given expressions a over b divided by c over d, where b and d are not 0, we can rewrite this as a over b times d over c, which is just simply AD over BC. And then we can simplify and cancel and do our good stuff. So the key thing is, just like multiplication, where we're factoring, cancel and all that, but we're going to take one additional step of flipping it and turning the division into multiplication. So let's look at some examples of this. So the first we have k minus 3 divided by 1 minus k squared over k squared minus 4k minus 3. So what I'll first do is I'm going to take this and I'm going to rewrite it as multiplication. So there's my first one, which I don't touch. I'm going to turn this to multiplication, but then I'm going to flip it upside down. Okay. So now if I try to factor it, we could try to factor it. Now the top, k minus 3. Now I made this one kind of intentionally. If you look at k squared minus 4k minus 3, if we try to factor this, 1 times negative 3 is negative 3. Well, the only things that multiply to negative 3 are negative 3 and positive 1, or 3 and negative 1, and neither of those factors will add to negative 4. So this actually does not factor. So we'll write this as k squared minus 4k minus 3, because it doesn't factor. On the bottom, I have k plus 1 from this guy, and now 1 minus k squared is the difference of two squares, 1 and 1, k and k. So it'll factor as 1 minus k, 1 plus k. But as you look at this, none of these things cancel out. There's nothing on the top and bottom that will cancel out. So this would simply be our solution. Now this doesn't happen often, but I figure I would show you one where it doesn't always have to factor and cancel. Okay, let's look at another similar problem. We have 2x plus 6, x squared plus x minus 2 divided by x plus 3 over x squared plus 3x plus 2. So it is division, as I can see by the division sign. So the first thing is I'll rewrite it by multiplying by the reciprocal. So instead of division, it'll be multiplication, but the x squared plus 3x plus 2 will be on top, and the x plus 3 will be on bottom. So now if I factor these, the first one I can just take a 2 out of. If I take a 2 out of, that'll be 2 times x plus 3. That's this guy here. Now if I look at x squared plus x minus 2, if I want to factor that, 1 times negative 2 is negative 2. Are there two numbers that multiply to negative 2 and add to positive 1? There are. 2 and negative 1. So this will factor as x plus 2, x minus 1. Again, I don't have to do the rectangle method if I don't want to, because this is 1. So I know these two numbers that I found are just going to be the numbers in my factor. So x plus 2, x minus 1. Okay, now if I look at the second rational expression, there's x plus 3 on the bottom, not much you can do with this guy here. And now I can try to factor x squared plus 3x plus 2. So again, it's got 1 in the front, so 1 times 2 is 2. So I'm looking for two numbers that multiply to 2, add to 3, which is pretty simple, 2 and 1. So x plus 2, x plus 1. And again, I can only do that. I don't have to do the rectangle because it's got the 1 in front. Alright, so now I just start crossing off what's the same. Because unlike the last problem, there are things that cancel out. The x plus 2's cancel out, pardon me. X plus 3's cancel out. I believe that's all. So we have 2 x plus 1 over x minus 1. And those definitely do not cancel because 1 is plus and 1 is minus. They have to be the exact same. So again, very similar to multiplication except for the fact that we have to flip it. Flip the division, turns multiplication, flip it to make it multiplication. So here's our final example, and this is just kind of a monomial example. So we have 12yz over 10yz squared, and I'll turn this to multiplication of 4z over 5y squared z. So again, I flip it. Turn it to multiplication. Only flip the second one. Only flip this guy. Now I'll start canceling out if I can. Or I can multiply across if I want it. It doesn't matter. Because these are not really factorable ones, they're all monomials. If I wanted to multiply them across, I could. 12 times 4 is 48. and I'd have 1y and 2 z's, because I have a z here and a z here. On the bottom I'd have 50, and I'd have y to the third, because I've got y here and y squared here, and I'd have z to the third. Looks a little cleaner if you do it this way, and then you can start reducing and canceling. 48 over 50, both divide by 2. So I divide those both by 2, I get 24 over 25. Now for the y's, I have 1 on top and 3 on the bottom. So if I subtract that, I have 1y, and it would go on the bottom because there are 2 y's, pardon me. It would go on the bottom because there's more y's on the bottom. Again, if you remember from earlier, it would be 1y on the top and 3 on the bottom. So 1 would cancel out, leaving 2 on the bottom. Then we have 3 z's on bottom and 2 on top. So if I subtract 3 minus 2, I get 1, and again it will go on the bottom because there are more on the bottom. So our quotient is 24 over 25 y squared z. So again, a lot of factoring. A lot of the problems that aren't monomials like this one will need factoring. But again, you're just really trying to cancel out the things that are the same after you multiply or after you flip and multiply. All right, please let me know if you have any questions on assignment 2.